Hi everyone. So this video goes with the two examples that I have explained in week number 6. In the weekly notes I go over briefly find the probability of a problem that has the word and in it versus or, which makes a huge difference. So I'm going to do both of those examples that I mentioned in the notes in this video. Okay, so I have the first one, find the probability of choosing a 4 of hearts and then a red card. So when I'm trying to determine what to do on these, the key word in this one is the fact that I see and right here, okay? Which means right there, there's 2 events happening. I'm choosing 2 cards, okay? So that's a big difference between the one that's going to say or, where I'm only choosing 1 card. So I'm choosing 2 cards, okay? Right there is how I really know that I'm going to use what we call the multiplication rule. So this word and, meaning I'm choosing 2 cards, is going to make me realize that I have to multiply these 2 probabilities when I find them. So I'm going to click to the next slide and kind of in general figure out how to find the probability of 2 events with the and then we'll come back and apply it to this one. So when we say independent, it would mean that the occurrence of one is not affecting the other. Okay, so in this one, I didn't write it right here, but I have it when I write it in the notes that this is without replacement. Okay, right there, that means that these are not independent, because if I take a card out, it automatically affects the chances of whatever the next thing is, because I automatically have 1 less card. So if this was with replacement, then these would be considered independent events. It wouldn't matter if I chose the 4 of hearts. If I put it back, my chance of getting a red, it wouldn't have mattered if I chose that 4 of hearts. So these are not independent. These are dependent events right now. Okay. So the probability of getting a 4 of hearts and then a red. Okay, so the first thing I'm going to do is I'm going to find what's the chance of getting a 4 of hearts. And I'm going to multiply it, because I'm trying to find an and, times the probability of getting red, given that I just chose the 4 of hearts. Okay, so the probability of getting a 4 of hearts, that's a unique card. Okay, so I have a 1 out of 52 chance of getting that. Okay, times, so if these were independent, the chance of me getting a red, and the chance of me getting a red versus, given that I just chose a 4 of hearts, is slightly different for 2 reasons. One is, when I chose a 4 of hearts, it was red, so I have 1 less red in this case, and I have 1 less card. Okay, so in this case, normally there are 26 reds, half the deck, but I chose one when I got that 4 of hearts, so I only have 25 reds out of, and I chose a card, regardless if it was the 4 of hearts, I chose a card out, so I only have 51 cards left. Okay, so if you multiply that out, I'll let you guys do that, and just do the multiplication out, and make it into a decimal, depending on how my stat lab wants it. That's your probability. So that's an and. Okay, so I'm going to skip to my next slide. I've got this multiplication rule. Okay, so if I want to find the probability of an event A happening and then event B happening, I can find the probability of A happening. Okay, so in that first event, in that first example, that would have been me getting the 4 of hearts. I can find that individually. And then I find the probability of B happening, but I have to keep in mind that A already happened. Okay, so sometimes this probability of B given A, remember this is what we call that conditional probability, sometimes I don't actually have to worry about A happening if they're independent. So if A and B are independent, then the probability of B given A is the same thing as just the chance of B happening in the first place. Okay, So the idea is I have to find the two probabilities and multiply them, and I have to keep in mind with this second one, probability of B given A, that A happened. Okay, so if we go back to that first slide, that example, okay, so this one is find the probability of getting a king or a red if a single card is chosen. So even if I didn't write this choosing a single card, I'm just getting a card and I want to find a chance of it being a king or a red. So that's only one card versus with an and, it automatically means I'm choosing two cards. So again, let's go to the and look at, I just want to show you with this one. Find the probability of getting a king or a red. So let's kind of use so far what we have for the rule. Okay, so the probability of a king or a red. Okay, so let's take the probability of getting a king and add the probability of getting a red. And then we'll start to see what's missing from our rule on the other slide that I had. So the chance of me getting a king, there's 4 kings out of 52. Okay, this is not an and probability. I'm using the word or, so I'm not assuming I took kings out, so it's not going to affect the chances of me getting a red. So I have 4 kings out of 52. I have 26 reds out of 52. So if I'm trying to find the chance of getting a king or a red, then either one of these will make that happen. But if you look at it, there's 4 kings, 26 red, but the red kings got counted in each one of these. Okay, we counted it too many times. We counted it in both the first one and in the second one. So what I do at the end is I take away those 2, that what I always kind of call the overlap, that got counted twice. Okay, this is the overlap. Now, if there is no overlap, if there's no way that getting a king and a red can happen, then I don't have to do that, or that end part is 0. So there are, in here, 28 ways out of 52 to get a king or a red. Okay, so let's go back to that other slide rule for this. So the addition rule for this one. Okay, so when I see, if I am looking at trying to find the probability of not two events, but event A or event B. Okay, this word, so it's one thing happening, but I can get A or B and still have what we would kind of call a success. So what I do here is I take the probability of A, okay, and this word or is going to make me add these 2 probabilities, because this is going to work if A happens, this is going to work if B happens. So my chances, I add them up to see what is the chance of A or B happening. Okay, and then we have this thing on the end, okay? So I'm going to go back, actually, I'm going to flip back. So this right here, if these are mutually exclusive, which I'll write that down in a second, if A and B can't happen together, then I'm all set here. But if they can happen at the same time, that means I'm going to have counted them here and here. So I had to take away this chance of them happening together at the same time. Okay? So let's just, this is what I was calling in that other one, that overlap. You can kind of see it if you do a little Venn diagram. Okay, so let's say this is A happening, the chance of A happening, and let's say this is a chance of B happening. Okay, you've got these pieces in here that got counted with both, and that's why we subtract them once. Okay, if, let me get a new slide here. If A and B are mutually exclusive, then that probability of A and B is 0, so you don't have to worry about it. That would be a case like, let's say, it would look like this. Let's say you had A over here, and B over here, no overlap. Okay, that would be like getting a 4 or a 5 when you're choosing cards. Okay, those aren't going to happen together, so you just have to add up what's my chance of 4s, what's my chance of 5s. So that's an example. Let me just put that right over here. Let's say we want the probability of getting a 4 or a 5. Okay, those two are mutually exclusive. Okay, so those are those two examples, one of an and, one of an or. So hopefully that helps you get started on this week's homework. And then just let me know if you have any questions.